Okay, so this was a doubt posted by Harshal. It's a percentage question. It's a very basic percentage question. Now, the major doubt that I believe Harshal had was regarding time management in this particular question, because it required a bit of calculation if you want to solve this completely. So I would like to discuss an estimation technique because we had options in this question, so we can estimate this very smartly. This was the question. So you have a particular laboratory experiment being conducted, and there's a type of bacteria which was found to triple in every 4 minutes. Now, what is the approximate percentage compounded increase in the bacteria population per minute? So for 4 minutes, the percentage change has been given, and we are looking for the percentage change every minute. So we have to scale back something like that, because it's compounded. So every minute, the same percentage growth will happen over the previous minute's population. You can put it in that way. So first of all, couple of important words. So first thing, you can check that any which way the question is looking for approximate. In these kind of cases, they would be looking for approximate only. And as I mentioned, so compounded increase. You're not looking for a direct increase. So not that there's a constant percentage change over the initial population. That will hardly happen anytime. It's always compounded increase only in these kind of cases. So, keeping these two things in mind, first of all, let's put the options, the four options that we have in a particular sequence. So, I put them in ascending order in this scenario. You can put it in descending also, but this is what I prefer usually. So we have 25, 32, 40, and 42 as percentage values as options, right? Now, also, let us look at the overall percentage change that is known to us. As it is tripling the population of the bacteria, so the increase should be 200%. This is very naturally figured out. So the increase is 200%, and had there been a constant percentage increase over the initial population, so had there been a constant increase over the initial population as the base, not on the current population, but on the initial population, then the per minute increase would have been simply 50%, right? This is also very easy to understand, 200 by 4. But if you look at the four options, you have 25% as one of the options, right? That is, I mean, it should be very easily understood that it's very low compared to what we are looking for. Because if you think this as simple interest and compound interest, simple interest being 50% for 4 year period, 25% is pretty low. But if you're not very confident, you can also test out this. 25% growth implies what? One-fourth increase. So if the population is increasing by one-fourth, it is becoming five-fourth of what it was in the previous minute, right? And this is happening 4 times. So the net increase would be or net population would be how much? It would be five-fourth of five-fourth of five-fourth of five-fourth of the initial population. So five-fourth to the power 4, which is 625 by 256. Now you can easily check that this 625 is not 3 times of 256, right? Because I mean, that is what we are looking for. So if the initial population had been 256 and the final population is 625 according to this ratio. So 625 is not triple of 256, not even close to it. So if you're not confident, you can test it out. It's not very time consuming to test this much out. So now we are left with three feasible options. I mean, not that I'm saying that all of these are feasible, but I mean, something which we cannot estimate very quickly. So we have 32, 40, and 42. In these kind of cases, always look at the middle one, because middle option will indicate not only that whether that is the correct answer or not, but it would also indicate whether the actual answer should be more than it or less than it. So if you are testing out with options, you can test with the middle one. And in this case, you can see that the 40% is pretty decent number also. This 40% increase, we can straight away get into fractions and all. So I'll use multiplying factor in this case. So if you have a 40% increase in each minute, so every minute the population becomes 1.4 times of that in the previous minute, isn't it? So 40% increase implies it becomes 1.4 times that it was in the previous minute. So in 2 minutes itself, you can see 1.4 square is 1.96, right? So in 2 minutes itself, it becomes 1.96, and that is almost doubled. So if it is doubling almost in 2 minutes, in 4 minutes, it should become 4 times of the initial population. So had we been dealing with 40%, then we are getting 4 times of the initial population, not 3 times. So our answer, which is more than required in this case, so our answer should actually be less than 40%. Now, out of the three feasible options that we have, there is only one option allowed. So that is less than 40 is only 32. So the answer is straight away 32. So this is one estimation technique that I wanted to discuss in this question. As such, there is nothing to this problem, but just this might save a bit of time. It's very fast to do also. 25% you can eliminate very quickly also. If you are not confident, that will take another 10-15 seconds, I believe. But testing 40% should be done very fast. 1.4 square is 1.96, almost doubled. So that's that for this question. So thank you.